All right, guys, so for your Quiz 1 study guide, I'm going to be going through number 8 up to the end of the study guide from here, numbers 1 through 7. They're just definition answers, and you can see those on the answer key that have been included. Okay, so for number 8, it says, let's suppose we have a function m of g equals t. G is an input and t is an output. Using derivative notation, we want to write the derivative of this function in as many ways as we possibly can. So we want to make sure that you guys know how to write derivative notation. So one way to do it is to do this, m prime of g. That would be one way to do it. Okay. Another way to do it would be to do the derivative of m with respect to g. Or you could also do the derivative of t with respect to g. The input goes on the bottom. That's important to understand. Now the top letter can be different. It can be the name of the function, which in this case is m, or it can be the output variable in this case, which is t. Either way, that'll work, but those are two different ways to write it like that. Another way you could write it is you could write it as the derivative with respect to g. Once again, that input variable has to go on the bottom of m of g. Technically, you could also write it like this, the derivative with respect to g of t. Since m of g and t are the same thing, as it says up here they're equal, then they're pretty much replaceable with each other. All right, so for number 9, we want to write two different ways we can verbally say this expression up here. There are two ways that we can do this. One way is we could say y prime of m. Or we could also say the derivative of y with respect to m. So there are two ways that we could say that there. All right, number 10, how would you verbally say this one? Well, this one's actually very much the same thing as the last problem. It's just that we wouldn't really, even though this is the derivative also, it doesn't have that little, like another, let me be more clear. Another way to write this would be like this. This would mean the same thing. It's supposed to be an E there. But we can call this one R prime. I would hesitate to call this R prime though when it's written like this. It technically, I guess maybe you could argue it's not wrong, but I don't see that little mark there, and that little mark is what we call a prime, even though it means the same thing. So how I would say this one is I would say the derivative of R, because that's the name of the function in here, with respect to E. E is our input variable, which is down here. It's also here. Now, but you're going to notice that this one has a little extra something here. And when it has this, they're actually telling you what E equals at a specific point. So this isn't just the derivative of R with respect to E, but this is the derivative of R with respect to E when E equals 2. Okay? Now, when they actually give you a number to plug in here, your derivative gives you an instantaneous rate of change of that function. So another way that you could say this is you could say the instantaneous rate of change of R at E equals 2. Okay, so just instead of saying the derivative, you could say the instantaneous rate of change of R at E equals 2. So those are two different ways that you can say that one. All right, let's go ahead and move on to the next one here. So this problem is actually very similar to the last one. You would say the same two things. So one way you could say this, you could say the derivative of v with respect to t at t equals 3. Or you could say the instantaneous rate of change of v at t equals 3. But you'll notice this one actually has something else to it now. It's telling me that the rate of change of v with respect to t at t equals 3, but then it tells me what it equals. It tells me it equals 4. All right, so that means we can actually add a little more to this. And I'm calling this an extra credit question simply because we didn't go over this, but it's not too big of a deal, honestly. The derivative of v with respect to t at t equals 3 is 4. Same thing down here is 4. So in other words, this is the actual slope of the function. It's the actual rate of change at that point. So the rate of change of v at t equals 3 is 4. Okay, so that's another one that we can do. All right, so number 12. Parts A and B are more extra credit questions. These ones will actually appear on your quiz as well. These types of questions, if you want to, they're extra credits. Once again, the only reason being because we didn't do it in class yet. It's not too hard, so I figured we'd throw it out there. It is something you want to know how to do, so I'm kind of like back teaching here, but making it extra credit. So here we go. So draw the secant line on the interval from x equals -1 to x equals 2. So we just want to find on our graph where x equals -1. That would be like right about here. And we also want to find where it equals +2, and that would be like right about here. So those are the two dots where x equals -1 and where x equals 2, and then you just go ahead and draw your secant line there, and you got it. A secant line is a line that goes through 2 points on your graph. I should probably make it actually touch both dots, though. I'm missing it. There we go. A little bit better, a little more crooked, but who cares? All right, so there's a secant line. So that would be one extra credit point you can get. Average rate of change. Well, to get your average rate of change, hopefully you guys know that means you need to do the slope formula. Now, we have the x values. They give them to us. The x values are -1 and 2. So I'll call this one the 1, and I'll call this one the 2. And so that's going to be x2 minus x1. Problem is I don't know what my y values are for those, right? Well, there's two ways you could do it. One way is you could just look at the graph. The other way is you could plug these numbers in. So I'll show you both. So I want to find, if this is x1, then what's y1 going to be? Well, all I have to do is I have to take my function here, and I'm going to plug the x1 in for it. So I'm going to plug in x1, which is -1. I'm going to square it, and I'm going to multiply. And there's my y2. So when x equals negative, actually that would be y1 because that's x1. So I plugged in x1, so that gives me y1. So I know my y1 is -2. Now another way you could tell is just by looking at the graph. At x equals -1, the y value is -2. So I'll plug that into the y1 spot there. Oops. All right. Next, I will go ahead and do the same thing to find y2. So to find y2, I'm going to plug in my x2. My x2 is 2. So that gives me -8. Or once again, you could tell just by looking at the graph that the y value at that point is -8. Oops. All right. So from there, we can go ahead and find that average rate of change. So -8 plus 2 is -6, and that's 3. And so my average rate of change would be -2. So that's how you can find the average rate of change, just by doing that slope formula. Another way you could do it if you wanted to get a little more technical is you could, or not technical actually, just using the graph, you could just see, oh, I went down 6 spaces and over 3 spaces. So that's my rise and that's my run. So rise over run makes -2. So you could use the slope formula, or you could just do rise and run from the graph. It doesn't really matter. All you really need to know is the average rate of change is basically the slope of your secant line. So you can use the formula, or you can use the graph. The trick is they give you the x values, but you have to find the y values yourself by plugging it into the function, or by just looking at the graph. Okay, so part A and B are extra credit because we didn't actually do any of those in class, but there you go. Let's do part C. Draw a tangent line at x equals 2. So I want to find where x equals 2 on my graph, and I've already done that. It was down here. And I want to draw a tangent line. Now, a tangent line is a line that is straight, and it should just graze my function right there at that point. And it should be a line whose steepness represents the steepness of my graph at that point. So that would be my tangent line there. Now, when I'm grading these, I want to make sure that it's hitting the graph at x equals 2, and it should also be going in the correct direction, and it should really only be grazing the graph at that point, okay? So let's go ahead and move on to the last one. The last one asks us to find the instantaneous rate of change. Hopefully you guys know that to find the instantaneous rate of change, you find the derivative of your function. Now my function is negative 2x squared, so I'm going to apply the power rule to that. I'm going to multiply the 2 times the front, and that gives me negative 4. And then I'm going to take 1 away from the power, which leaves me with 1. And to find the instantaneous rate of change at that point, x equals 2, all I need to do is plug in 2. And I get negative 8. So the slope of my function at this point, or the instantaneous rate of change of my function at that point, is a slope of negative 8. All right. The rest of our problems here are just applying the 3 derivative rules that we've learned so far. So let's go ahead and begin. So for part A, anytime you have y equals a number, this is what's called a constant function, and therefore we're going to apply the constant rule. The constant rule says that anytime you have a constant function, its derivative is always 0. Let's go ahead and take a look at part B. This is a linear function, and anytime you have a linear function, to find its derivative, you're going to apply what's known as the constant multiple rule. And according to that rule, the derivative is basically going to be whatever that number in front of the x is. All right, now the rest of these are all going to be the power rule. Okay, so these first two were the only exceptions, but the rest of it is all going to be the power rule. So I'm not going to write that, but just so you know, the rest of these problems will be that. So the first one is a basic power rule. According to the power rule, the derivative is attained by taking the power and multiplying it to the front, and then taking 1 off of the power. And so that would be the answer to part C. Part D adds an extra layer, and that this one already has a coefficient of 3. So all that means is that when you take that power and put it in the front, what you're going to actually do is multiply it. So 3 times 3 is 9, but you still just take 1 away from the power. So that would be the power rule for that one. Part E kind of shows you how to handle fractions a little bit. Once again, we're going to multiply this power here to the front. Now we're going to take 1 away from the power. Now for these ones, you're going to want to simplify, so I'm going to put that over 1. And then we're going to we're just going to multiply, or you could cross reduce if possible. And we end up with y prime equals 2x to the 6th. Take a look at part F here. Now part F, and most of these problems, with the exception of H now, but almost every other problem up here is going to require us, maybe even H does too, they're all going to require us to rewrite it. Okay, so let's go ahead and take a look at F. So we start off with 5 over x to the 3rd. Now the first thing I'm going to do is I'm going to rewrite this so that it's power rule friendly. So the way we do that is we're going to rewrite it where I'm going to put x to the 3rd on the top and make the exponent a negative. That's a rule about exponents. Having a variable with a power on the bottom is the same thing as having that variable on the top with the opposite sign. Okay, so now that I've rewritten it, now I can apply the old power rules we're used to applying it. So I can just take this and multiply it by the 5, and I get negative 15. and then I can take 1 away from my power. Now you got to be careful when you have a negative power and you subtract 1 from it, it becomes even more negative. So now it's -4 as a power. And even though this is a possible answer, I would be prepared to have it in rewritten form. So anytime we're doing these rewrite problems, you might have to rewrite it at the end also. It's multiple choice, so you're going to have to be able to identify the correct answer. Another way to write this would be -15 over x to the +4. Okay, so that would be part F. Let's go ahead and take a look at part G. Part G has an added little twist to it. I can't remember if we did any of these in class, so I want to make sure that we do one here and now just to make sure all of our ends are covered. I'm going to rewrite this once again because it's not power rule ready yet. Now the way I'm going to rewrite this one is I'm going to go ahead and I'm going to rewrite it as 3/5 x to the -2. So instead of having the x down here, I'm just going to move it up next to the fraction like I'm multiplying it. Okay, now I'm skipping some steps. I think maybe when we went over it, I think I did go over this stuff a little bit in class. Here's another way you could think about it. If you have 3 over 5x squared, another way you could write that is 3 over 5 times 1 over x squared, right? And that's the same thing as saying 3/5 times x to the -2. Okay, now you don't have to do this middle step like I skipped it. You can skip it too. Just want to make sure that you understand. So we're going to rewrite it so it's power rule friendly. And now we go ahead and apply the power rule. So I'm going to multiply 2 to the front, -2. And I'm going to take 1 away from the power. On this one, I can't cross reduce. So I'm just going to simplify by multiplying straight across. So I end up with -6 over 5. And then finally, we can rewrite this as -6 over 5 x to the 3rd. I can take that x to the -3 and move it to the denominator so that its power is positive. Now, this is a possible answer also, so make sure you know how to write your answer in a variety of ways. All right, let's go ahead and take a look at part H here. Okay, so my derivative, I'm going to multiply that 3/4 to the front. I'm going to take 1 away from the power. Now, if you don't remember how to take 1 away from the fraction, basically you could do it the long way, where you write it out like this, 3/4 minus 1, and get a common denominator and simplify it. But the short way that I share with you guys in class was basically anytime you subtract 1 from a fraction, you just do top minus bottom. So 3 minus 4 is -1. And then you keep the denominator the same, 4. So, all right, so there's that. I'm going to multiply straight across. Actually, I can cross reduce here. The 4 goes into the 8 twice. So I'm left with 3 times 2 in the front, which is 6x to the -1/4. Now, that's one way that the answer can be written. Another way the answer can be written is like this. Another way that that answer can be rewritten is like this. A fraction power works like this. This number is the root, and this number is the power on the x, but since it's a 1, we don't really need to write that. Okay? So these are all possible different ways that the answer could be written in your multiple choice test. So you want to make sure that you know how to do all 3 of those. All right, let's go ahead and take a look at I. All right, so this is another rewrite problem. So I'm going to start by rewriting this. It's going to be x. This is going to be the numerator. This is going to be the denominator of a powered fraction there, a fraction power. Once we have that, we're ready to go ahead and do our derivative. Multiply the power to the front. Subtract 1 from the power. Shortcut is top minus bottom over bottom. Once again, we can write that in a few different ways. One way I can write this is as 3 over 5x to the positive 2/5 on the bottom. Or I can rewrite that as 3 over 5 fifth root of x squared on the bottom. So those are three ways that we can have this answer expressed. Let's go ahead and take a look at J. So once again, we're going to start by rewriting it. And this one's a little bit confusing though because we're missing some numbers, but when you have a root without a number right here, that number is a 2. And when you have a power without a number here, that's a 1. So if I were to rewrite this, it would be x to the 1/2. And now we can go ahead and apply our power rule. I'm going to multiply the power to the front. I'm going to take 1 away from this power, which would be negative 1/2. And that's a possible answer, which can be written in two other ways. And there you guys have it. Let's go ahead and take a look at letter K. Okay, so once again, we're going to rewrite. Now you could leave that as 2/6, but there's no reason we can't reduce that. I would say just go for it. Why not? 2 over 6 can reduce to 1/3. Now if you don't do that, I guess it wouldn't be wrong. It'd just be, your answers may not come out to be obvious because you would have to reduce things. So I would encourage you to reduce if you can. But anyway, go ahead and multiply your fraction to the front as you take the derivative. So that's 1/3 times 4. Take 1 away from your power. And that's 1, well, actually we'd have to write it like this. So that's one way you can write your answer. Another way would be 4 over 3 x to the 2/3, or another way would be 4 over 3 cube root of x squared. So those are three possible ways to write your answer there. So these are all power rules from part C and down. Those are all power rule examples, finding derivatives of power functions. And that does it for our study guide. So I wish you guys luck on our first quiz on Wednesday.